Okay, if I go over here, all right, sound not muted, but you can't see that anymore. But I can tell. And I've got the secret thing. The thing I'm trying to figure out is, all right, so these ones, nope. I can't display this to you because it's on a different scene, and y'all are just going through the scenes. So I have on my starting soon scene, which I can't show you, a starting soon PNG image. And I can open the source properties. Where is it getting this image from? Oh my word, is it like, so it is hiding it somewhere in the application. That's like the worst place possible. If this crashes, this thing's gone. Okay. Whatever. I can't do that. Can't take care of that. So I'm gonna go back to the secret. I'm gonna give it a source. I should at least make a directory for the files that I have, which I thought I had somewhere. All right, I'm gonna create a new directory in my documents area, and I'll just call it stream. And then I'm going to go to the downloads, find the new download. Where'd it go? Chat GP. Oh, here it is. And then I know y'all can't see what I'm doing. Apologies. We'll hopefully be done with this pretty rapidly. So I've got the image. I want to rename it to something simpler. We'll do rename. Why is it wanting to rename the extension? It's so weird. We'll call it secret.png. And then hopefully this will just like pop into existence as soon as I get this right. So I'm going to browse to the file. I'm going to go to my documents, my stream directory, put in this secret and see what happens. Okay, cool. Let's go. That's in frame. Yeah, John, I am. So I was. What I didn't. Yes. The short answer is yes. I am planning to do some Love2D stuff. What I wanted to do first is like do some stream modification. I'm gonna put this down. Oh, okay. So apparently, why is my camera not all the way at the bottom edge? Has it been like that for a long time? Huh. I guess it has. Well, now this is off too. That's annoying. At least they came in roughly the same place. Okay, so we've got this now. Is that too weird with it like right over my skull? Maybe. There we go, just a little bit off to my shoulder. So now if I had to like show some configuration, we would go there. Let me do my buttons. So I've got my scene button and my secrets button. Cool. And you know what's so cool about, or one thing that's so cool about this to me, not only is it amazing that it could take that style and do that like in no time, that's phenomenal. It's that the text is right. Like even 6 months ago, that text would have been very difficult to get right. Okay, so let me carefully move this off to the side so we don't resize and crash. And I guess you see the directory where I created the secret file, the secret PNG. That's all that. Okay, so let's, and I might do that a couple times this evening, like as I'm trying to build out some different pieces. Something else I'm really interested in doing is figuring out Figuring out what? Figuring out like background music? Because as I'm switching with this style of stream, I think what I want to do is a lot more kind of chill, where I don't feel the need to talk with every moment of the stream and get a little bit more code done. Also, I don't know, last week even, I would say not a whole lot has changed from the gameplay, although I did fix, you may not even recognize it there, a problem with the paddles last time was that if you hit in the middle, it would slow things down. I fixed that gameplay element, but other than that, I didn't really change anything else with the gameplay. What I did change, which should be pretty obvious if you saw last week, is last week this was all black and white. So I had ChatGPT make a background. I also added a place to hold the score. Okay, so there was a place to hold the score before, but I got a custom font. So I did a little bit of homework on like how to get custom fonts going and all that sort of stuff. So my goals are still kind of the same, of learn how to make games with Love2D as best I can, and like I think I might try and make some other classics like Breakout, or I don't know. I'm not sure exactly what I'm going to pick yet. You can see there is some weirdness with the controls. I did let Grok do all of the stuff here, and I think there's some oddities around. If I hit at the edge, the side of the paddle, it behaves weirdly. So I was thinking about some features that I might want for this week to work through this. Is still am interested in having better menus, which I don't have yet, because one thing that's important to me is the game code has like a game loop. And on a very simple system, oh, that'd be cool. Maybe Tetris, that'd be tricky. The game code has a very simple loop where you have a place where you can load stuff, which makes sense just for the initial load, and it has a place where you can update logic. Whoa. Okay. You can update logic, and then you have a place where you draw. And that's all well and good if you have a simple game that's just kind of doing one thing. But what happens when you want to draw a different kind of thing, like a game menu? Like, how would you pause a game? How do you stop all state from updating so that you don't let things continue to run in the background? I want to learn some patterns for doing that, because I think that's going to be necessary to make not even just complicated games, but even like a game like this is like, it's great. It starts out with a going right away, which is okay. But what if you wanted to be 2-player? What if you like didn't want to have the other player be a CPU? So these are the things that I'm thinking about. So that'd be one nice addition. Another one that would be fun is, and always a crowd pleaser, at least for me, when I've seen it, other people do it, and I've done it myself, is particle systems. Like, you could make it so that every time the ball hits the paddle, that like sparks fly. Because I mean, I've got my it's kind of like sci-fi pong here, so it'd be cool if like little colored pixels flew off the paddle or something, in like a splash of color. So there's probably some stuff to do, particles, and maybe even some shaders. If you've not done game development before, a lot of these things are new to me. I just know some of the names. But shaders are this idea of when you want to make an effect that applies to every pixel in a certain area, then you apply this shader. Use a very specialized language. It's pretty heavy on math, frankly, so it's one of these things where I will probably look for somebody who has written a shader. But Ah! Oh, hey, I won. Um, and like an example of a shader, like let's look up one that's really common, is a chromatic shader. I'm sure you've seen this before. Chromatic shader, where it like splits up, where you've seen the effect where like the red and blue kind of get split from an image. Here it is. So this is an example of a shader where this would have been kind of all of this dark color here, where it's all the main colors are on top of each other properly. But there's a kind of shader where you can like move, where you can look at the pixel and say, I want to move the cyan, the blue that way. I want to move the red up. I want to move the yellow that way, and pick them in different directions, and it kind of splits them out in this exploded chromatic look, where you see all the actual color separation. It's a pretty common one. In fact, I want to say there's a game that I played called Hyperlight Drifter that I felt like used a bunch of this kind of shading effect with stuff. This was a pretty cool stylized game. I'm nowhere close to making anything this cool, but this game made some pretty neat effects that I think use chromatic stuff. So that'd be cool. So let's try. Still love running. So I did it like it's a crappy menu. It's not considering the new font stuff. I have to tell it to, hey, you didn't get that in the right place. I had to do that for getting the player and the CPU. Yeah, that's the kind of the next directions I want to go in. Also want to get reminders from Grok about things I said I wanted to do. So let's go to Grok. And I don't remember which conversation it was. So history and pong. Okay. So let's see what it offers up as a suggestion. Because that's what I was doing. Please test the custom font. I don't want to cap the ball speed. That's boring. We could redefine. So the CPU API is pretty rough, right? Like it perfectly tracks. So that might be a good one. Because I didn't know anything about developing computer AI either. So let's try that. Let's let Grok continue to guide us for a bit. So here we have main file, and I think what I'm going to do, because I don't remember what code is here, I'm going to paste in the code. I'm going to say please refine the CPU AI. Here is my latest code in case there are any differences with what you have stored. Like there's a context of what goes in there. So the CPU AI is pretty dumb in that it just kind of tracks the ball position. Like you can watch it when it plays. It's just kind of going up and down at a rate that is matching the vertical position of the ball. And let's see if we can even show that. That's going to be in this update code somewhere. And see, the problem is like Grok goes back and forth between like ripping the comments out or putting them back in. So I think it's the right paddle, right? Okay, so you can see it here. Here's the basic code. It's like doing a calculation based on the Y position of the ball and the halfway of the height of the paddle. Then it figures out how far it is and starts to, with every update tick, it tries to move closer to that. But it's pretty merciless. Like there's no, I think what they were commenting on is that it plays too perfectly. Like if it gets up to speed, it gets to a point where I can't do anything. So we can add some imperfections, kind of making it more human in some sense. Okay, so it says we've got our latest code. It matched what they had stored. That's great. Yeah, AI is too perfect. Tracks precisely and moves instantly into the ball's Y position, making it hard to score. So we're going to give it a reaction delay. Okay, so like a timer. I'm interested to see how it'll do this. Simulating human reaction time and then imperfect tracking. Instead of always tracking, add some randomness or offset to the target position, making the CPU miss occasionally. Okay. So it describes the current. Okay, we found the right code. This is what describes the behavior. The CPU never misses unless the ball moves faster than the 250 pixels per second vertically, which is rare, even with 15% speed. Yeah. And I experienced this. Like it was hard to beat the computer. I mean, it's kind of fun when because you have to get up to speed. Probably would want to make it go faster. So, all right, we told us conceptually what it's going to do. So after what I'm going to do is going to copy and paste the code in, because we're not going to be able to see it in the way that it's just going to put all the code in here, and so we'll be able to get the diff to see it. So we'll get the reaction delay, imperfect tracking. Oh, there's some balance stuff here. Okay, cool. Let's copy this. Let's go back to the top. We will change all that and paste this stuff in. And before we look at it, because Grok is just an AI, no offense to my future overlords, just an AI today, let's make sure that it actually seems to play. It's kind of jumping around, kind of spazzy. So I think maybe this is right, but it feels like a crazy person. Like look at that. This is, I don't know how much you can see that. Like it's awful now. Okay, so we're gonna have to tell it to, if it can, like, what characteristically, what feels wrong with it? It feels like it's jittery. Like, you know, as a human being, I go for a while and then I stop. I go for a while and then I stop. So I kind of track and then I move. And then this is, they're like amped up on caffeine feeling, right? Like they're no, it's really weird. And you can see it's so bad that I'm just, where previously in a moment ago when I was playing against it, I was evenly matched after playing it for a while. This version feels not very good. Although it finally did it when it got to speed. Like it just missed the first serve. That's so not good. Okay. So we've got some feedback for Grok. Let's tell it what's up before we actually take a look at the code. I'm not even gonna bother reading all that stuff because I think it'll repeat a lot of it. I tried out the new AI and it felt super weird. The behavior of the CPU was very jittery. Also, what's the right word? Also, well, I'll describe it the way I play it. So a human would play with fewer movements. There would be longer periods of time of moving toward the ball, pausing to assess where the ball might be going, then resuming. Can you simulate that behavior and remove the jumpy and jittery behavior of the current AI? Now, also, we might periodically want to lean on the think button. So I had a problem. So I said last time the ball when it was hitting the paddle and it was hitting it in the middle, it would bounce back, but in like slow motion, would be really slow. And I said, Grok, you need to fix that. Like I want to keep the behavior of how things were jumping off, but I want it to be so that if you hit the ball in the middle, it never slows down. So in the process of describing that, it totally messed it up basically. So what was happening is it would hit the paddle, and then there'd be some kind of weird collision detection. So it'd like do, and then it would shoot off backwards, and score a point. So it was whoever touched the ball first would lose because it would have this weird behavior. So I told it was wrong, and then it would correct it. And so what it would happen is it would correct the weird jittery behavior, but then it would return the speed slowness, where if it hit the middle, it would slow down again. So it was incapable of doing both at the same time. And when I switched to using this think button at the bottom, spent more time coming up with an answer. And the answer, I mean, is what you've seen. It's not perfect. It still behaves weird when it's hitting the top or the bottom of the paddle, but it's way more sensible than what it was. So we might have to do that here if we can't get better AI out of it. We might have to put it in a think mode. Let's see how it goes with this feedback. Okay. Kai, welcome. We're doing a pong clone. While Love2D is, or sorry, while Grok is working on that, here's what it looks like. We're trying to make this better. Right now, the CPU paddle behavior is really spastic. And that's really just not that fun to play with. It's almost like playing with a person who like has maybe like a physical disability with their hand motion. I mean, not to belittle anybody like that, of course, but whoops. But just like this jerkiness feels like a motor problem. It doesn't feel like playing against a person. Okay. Anyway, that's what's going on. We're trying to get that corrected to have something more natural. So, okay. Moving by this results in these tiny movements even when the paddle is close to the target. Humans don't move constantly. Move toward a predicted position positive. Yeah, cool. Glad that represented that right. Predict the ball trajectory. Trajectory. State-based movement? Oh man. They might be getting a lot more advanced here. They're going to put in a state machine. This could be a big change. Okay, well, let's see how it does. Seems like a lot more code, but I could be wrong. So let's take this, go back here, change it, paste it in, and then we've got this. Don't know if it's any good or not, so let's see how it did. Whoa, the ball just like came out of nowhere. It totally messed something up. That's not even moving. Okay, Grok, you failed. But oh, the game's dead. Something's going on. Ah, get me out of here! Don't kill my stream. Okay, goodbye. Stop. Stop. Wow. What are you doing? Go away. Force quit. Okay. So that was bad. Hmm. What did you do? So you can see it took out, it likes to do this. It likes to take out the comments. Predict ball position. Okay, well, I think what I'm going to do is say something is quite wrong with this change. The game is not behaving in any predictable way anymore. Can you inspect and figure out what is wrong? Notably, no E, right? Notably, the CPU paddle isn't moving at all. Okay, so here's what I'm going to try and bring in the big guns, let it think on it to craft a response and come up with something. The nice part is about with this is that I've used Git, and I've generally been doing a commit between each change that I'm making. So it's not like I'm in some unrecoverable state. The downside is that this thinking process takes some time. So what this might take I think it'd take like a minute and a half. But it's not too bad. So let's think about what else we will want it to do. If this doesn't work out, I think it might be easier to switch to like leave the AI where it is as something simplistic but not realistic, and try something just more fun. Maybe that's more sound effects, maybe that's particles, something like that. So it's gonna think, and then after it's done, it'll just kind of dump it all to here, and we'll have the code. I don't even really care what the problem is because they did the problem. So I don't. This is one of the things with AI. It's like y'all made the mistake. Fix it. Whatever you need to do. So they feel like they have it. Critical, they're fixing it. Okay, okay, okay. Verify. Additional checks. Final fix and debug. Okay. Cool. But I don't want to paste in all the pieces. Please show me all the current code. Why is it taking long to think on this? Oh, I left the think button on. Dang it. Well, okay, that's my fault. While we're waiting for that, let's see, how do we do... Anybody know much about like YouTube background music? Stream background music. Music for live streaming. Chill vibes. How can I add? Well, that sounds like the right question. How can I add royalty-free music to my gaming stream? I mean, I'm not a gamer, but YouTube offers royalty-free music for free. Well, that's redundant. They're boring. Well, I don't need boring. I just need like me not talking all the time. No, no, no. Don't just stream from YouTube. That's a guaranteed way to like get not royalty-free music. Seems like a bad answer. All right, maybe this is not something I can really do like live on stream. Okay, let's try taking this whole thing. I think it should be, yep, it's all included. Come over here, change all the stuff, paste that in. Does it work? Nope. All right, you failed. Oh, now it's working. What? What is going on? Ah, did it again. All right, it gets us like some infinite loop and then just stops. Okay, go away. Go, go. Shoo, shoo. Okay, I don't like that I have to hard kill that stuff. Okay, I just don't trust their state machine. So let's do this. I'm gonna tell it turn off the think button, and I'm gonna give it my previous code. Let's actually make sure that it is the previous code, should be, and try and run this. This should be back to, yeah, it's tracking perfectly again. So see, now that you can, because once you understand that the code, how the code works, where it's just following the ball, you can kind of tell, you can almost even see it of like, as it gets there, how it just follows it. Anyway. Okay, so we're gonna go back here and we're gonna copy all this. I'm giving up on that feature because it still isn't working correctly. We can return to it later. Here is the code that I'm working from. let's say, what do we want to say? Next, let's add some particle effects when the ball hits the paddle. I think it would be cool if there were square pixel sparks, I'll put in quotes, that came off the paddle on impact at the point of impact. I don't know if we can do this natively or need some third-party library. Okay. Oh, there's a particle system. Specifically, you want to add square pistol. Yeah, that's repeating me. Particle system. So we've got the documentation. Is that a physics thing or system? Where is it? Graphics? There it is. Used to create cool effects like fire. Whoa, look at the surface area of that API. Holy moly. That is a lot of functions. Or methods. Okay. Hope you know what you're doing, Grok. Okay, so Love2D's particle system is designed for this kind of effect. It allows you to spawn, animate, and manage multiple particles like sparks with customizable properties such as size, shape, size, speed, direction, lifetime, and color. So we don't need a third-party library. Or we don't for now. Maybe there are better ones that will allow you more power or more simplicity. I don't know. Create a particle system for each paddle to emit the sparks when the ball hits. Use a square texture to give the square pixel sparks look. Configure properties. Okay. Trigger sparks on impact. Update and draw. So detect when the ball hits the paddle, which we already handled with the collision code. At the point of impact, calculate the exact y coordinate of contact and emit particles from that position. That sounds right. And then update the particle system each frame to animate the particles. So it's probably something where like you create a particle and each frame you say draw or something like that, and it progresses. It says like there's a lifetime for each of these things, right? So the particle knows what it's supposed to do on the next update. Creating a square texture. Do we have to create this ourselves? Requires a texture for its particles. To create a square pixel, sparks will generate a small square image, 4x4 pixels, using Love Graphics' new canvas. We'll fill it with white color, which allows us to tint the particles later. Okay, so maybe we don't have to make an image, but just kind of create one in memory. 2 particle system instances. Reasonable. For the texture, the emission rate, only when they hit, not continuously. Short lifetime, speed and direction, small squares. Okay, neat. You have to figure out where they go. We need a burst. 10 to 20 particles. All right, so we're going to update and draw. Let's just take it all, see where they put it. Okay, so we've got a bunch of properties that get set on this. Okay, so there's a canvas. That's the 4x4 thing. That's going to be the texture that they need. So create a canvas. We set the canvas. I don't know why. Give it a color and a fill, and then unset the canvas. I am confused about this. Okay, well, whatever. We'll figure it out. So there's the spark texture. So there's a particle lifetime, which way it's going. Now look at this. We've got, notice the sign differences. So the left particle has -50 and -50 here. I don't know what all of those three are, so we could probably look at what those are. Sizes are the same. Colors are the same, yellow to transparent. It's not continuous, and how long it emits. Okay, seems pretty reasonable. And then we have a place where we actually set it on the collision. Emit particles. How many particles to emit? So that's where they start. That's the emitter. And then we do an update on those after the particles are set. And then when we draw each particle. All right. Seems pretty cool, pretty straightforward. I hope it works. Let's try. Nope. Man, Grok, you're just like failing. Okay. Well, that's a bummer. Huh. What do we do with that when it doesn't show at all? It's one of the this is going to be one of the hard parts about doing like game development stuff is like I don't know what tools you use for debugging. What do you even? I guess you can make something simpler. Okay. Well, let's try. Okay. It's still playing. Oh. Okay, what did they say at the bottom? We shouldn't have any performance issues. Something is wrong with the change. Not seeing any particles at all. Particles at all. Where? I'm trying to think of like maybe where it's drawing. No. Because it's only fonts that come after it. What is wrong with the code? I don't know. probably should have asked, like, how should I check this? And we may need to do like simpler demos. Like something we could do is if Grok can't get this, we could say like make another game or another demo and just be like a particle demo. Show me how particles work. And that way, once I have an understanding of particles better and like see them in operation, then I think we might be able to come back in and say, hey, here's what was wrong. So so we should just look and see if the particles work at all. Are particles invisible due to properties? Okay, so we've got a new set of code here. Don't know what they did. Let's check out what they did. First of all, let's see if it actually worked. Nope. So it's got some debug output there. I don't know what the 70 and 730 are the same each time. I don't know what that's about. Maybe that's just the... Oh, you know what that probably is? That's probably the X position. Yep. The X position is going to be a constant thing. Oh. Okay. So it failed. I'm not going to keep that either. So let's do this. First thing I want to do is move the actual game assets. So let's exit out of here. Let's create a place for Pong. Because I think what I'm going to do is keep this repository around for maybe multiple games and demos that we might do in the future. So let's do a directory for Pong. And let's make that. And we want to move main into Pong. We want to move assets into Pong. And we want to move sounds into Pong. So Pong should have the whole game in it now. And now I should be able to still call it, but call it like this, Love Pong. And that way we can create any other little demos that we have. We'll go in here. Okay. So that's good. Let's add all that. It should be everything just renames, right? So that's all the files. We'll say move all Pong files into a dedicated directory. And what I want to do is this thread with Grok has gotten really long. So let's create a new one. Okay. Let's see. I want to do a particle demo using Love2D. Let's start with the most basic particle setup that you can craft. I wonder if it's because of the new canvas thing, if the canvas didn't work. Because it's making the particle system with an input there. And we go to the other one for a moment and look at the code. The other one was a, what do they call it? It wasn't an image. It was a canvas. So created this canvas thing, filled it. Okay. So let's look at the particle system. They've got graphics, new particle system. So go here. And we want to look for new particle system. And it says image to use. Oh, here's another one though. So it also has a variant where it can work with a texture, and a texture can be an image or a canvas. So it should, if it doesn't seem like the fact that we used a canvas was the problem. But let's try it. Let's go back to our conversation. Create a small image. If you want to avoid creating an image, add this to the love load. Okay, I do want to do that. So let's take this. Let's make a new directory called particles. And we will, I guess, yeah. Go into particles, we'll make a main file. And we will paste what was there. Duplicate field update? What are you talking about? Is it because it's seeing the other one that I had? Oh, that would be annoying. I think it might be. All right, let's navigate into the directory so it only is aware of this game that it's currently on. Because I think that's what's, I think it's seeing like the other main file. Which is dumb, but why are you telling me this? Duplicate from where? Duplicate field. Load. Huh? Is the other main doing this now too if I go to the other pong? Duplicate field. Okay. If I remove particles main and then open up main here, is it still going to complain about that? No. Ah, phooey. I'm not in that directory. That's what I don't get. Like, I'm literally in a different directory. How does it have visibility? Okay, whatever. I'm going to leave it for now. We'll figure it out. We're going to, though, come down here and switch the load. So copy that, and then we're going to change the function to this other load. And now we can do love particles. Okay, that's working. So something about the other particles that we had yeah, I don't know what's going on. So let's take a quick. Oh, it's based on where the mouse is. Ooh, that's cool. Oh, that's just fun. But we could hide the mouse cursor, and that'd be really fun to play with. Okay. So what's it doing? It John, you think the duplicates are from Docker? I wouldn't think so. I'm running this straight. There's no VM here. We're running it straight from the Mac. So I don't know what path visibility it has. Yeah, not sure. Okay. We're creating a new image, or a simple image. Create a soft white circle. Doing the distance formula by taking the square root of the two deltas here. I don't understand this code at all. This chunk right here. If the distance is less than 8, then do 1 1 oh. This is the alpha channel. So it's saying, because this is RGBA, and the alpha, if the distance is big up to 8, then if it's 8, then you get a 1 here, right? Or if it's 7, you get a 1. Oh, I see. So for the farther you are away from the center, the bigger this number will be, and the more transparent it will be. Oh, bundle it. Yeah, I don't know if that would play well. Like, I have no idea if Love2D plays with Docker. I mean, it might. I just haven't even thought about it. It's greater than 8. Make it transparent. I don't understand this part right here. Why the whatever. I don't really have to understand, I guess, every piece of this. So we're just making a generic image canvas thing. Actually, I want to be learning the system while I'm doing this. So I want to learn at the same time. So let's figure out what new image data is returning. Is that a canvas? The problem, so I've got LSP running, but it does not know love right now. So I bet maybe if I do, I saw somebody else do this the other day. So they added to the global and said require love. That should still work, but I'm hoping. I was hoping that this might like make the LSP know how to find new image data, because love would have it would actually map somewhere. What if I say this and do local? That's probably a bad idea. Come on. Oh, you know what it could be? It could be that because I'm running love, and this program probably has the Lua interpreter. Like, I can't, like, if I go here and I'm on Lua and I just do require love, it's gonna be like, what are you talking about? Yeah, that's the problem. It can't find it. It looked in all the places that the Lua interpreter is aware of, and it doesn't know, right? So when I'm in the editor over here, the LSP, the language server, is looking in all of its allowed paths, and it's like, I don't have love installed. I'm not sure what you're talking about. So that seems to be the problem here. So maybe really what I could do is I could probably do, what do they call it? Lua rocks. If I installed it from a Lua rock, I'd get the love files, and then it would probably let the LSP work, but I don't know if that's worth it. My Steam Stream Deck is showing a 0 counter. Is the stream alive? Okay, still alive. All right, so I guess we'll just have to depend on the stuff over here. We'll go to image and new image data. And it returns an image data. If data isn't supplied, each pixel's color values will be set to 0, including the alpha. It's basically a transparent. You don't set anything. So you create so this thing is creating this image data thing that's a 16 by 16 where all the pixels are set to 0 and the alpha. Look at image data. I'm gathering its raw decoded image data. You can't draw image data directly to a screen. Okay, so it built this image data, and then wrapped that in an image object. And the image data has a map pixel which has a function which can take a whole bunch of things. So we only use 2 of them. We use the X and the Y. I see. Okay, this is all making sense how this is produced. So this is I imagine it goes through every pixel. Let's see what it says. This function is called with 6 parameters for each pixel in turn. So we got 16 by 16. That's what, 256, right? Is that right? No. Man, come on, brain. 16 times 16. Okay, that was right. 256. So it calls that 256 times and does some computation. Most of the pixels, this makes sense why we have this thing at the bottom now. So most of the pixels are going to be outside of the range that we care about. Like if it was creating a little circle, and there's like 4 corners, right? And all of those corners need to be transparent. But if you're within that circle, the distance formula is within that circle, you're less than 8. So is it from the center? Anyway, I'm sure this makes sense. Some kind of triangle somewhere. Then it radiates out from that circle. I'm not 100% tracking with this little bit of math right here. Like, let's think about this. If we have 0, 0 as like the first corner, then you're going to get -8, -8 as the dx dy. So that gets you -8, -8, that's 64, plus 64, that's 128. And the square root of that is 16. So the distance is 16. The distance is definitely not less than 8. So it's going to return transparent pixel. So that corner pixel is going to be transparent. Then let's think about the other corner, like with the X corner, the upper upper right. So that would be 16, 0. So we're going to have 8 and minus 8. So we'll get minus 64. No. Same number. Sorry. So 8 times 8, that's 64. Minus 8 times minus 8 is also 64. So we'll also get a 0 here because it'll be, or we'll get a 16 here, which will then go 0, 0, 0. Okay. Pick in the middle. So 8, 8. That gives us a 0, 0, right, for dx dy. So then you get 0 plus 0, square root of that is 0. You get the distance is 0. Then you get 1, 1, 1, 1. 1 minus 0 over 8, which is fully, that's just going to be another 1. So full alpha channel. So the middle is all the way opaque. Okay, cool. Neat. Neat little way to do that. So we've got the image data. Like, is it just for making, programmatically making certain kind of images? Like, that's a weird way to do something, but maybe it's just a convenient method for what we just did. Creates a screenshot. Oh, this is deprecated. I think that's what that means. Minus 11. So it's like, don't use this anymore. Okay, so you can get the raw image data from a file and then read pixels out of that. Huh. Okay. So why do you pass it into an image then? What's that about? Let's go back to the image section. Why do we make, what's it called? Oh, no, it's the graphics section. What's the difference between image data and an image? A drawable image type. Primary responsibility of Love Graphics is the drawing of lines, shape, text, images, and other drawable objects onto the screen. Loading external files into memory, creating specialized objects such as particles or canvases, and managing screen geometry. Okay. Then you get the lesson about how geometry works in Love2D. So 0, 0 is the upper left corner, and positive is down and to the right. And that's pretty universally true in most game engines that I've seen. Angles are expressed in radians. Oh, that's interesting. Be careful with that. Many functions manipulate the graphics coordinate system. Okay. So dig into image a little bit. Image has some methods. I don't know what all these texture things are. These functions have parentheses in odd places. This is because the image namespace is reserved by MediaWiki. Oh. So this is not, you would never see this. Like, okay. Artifact of the wiki software. A drawable image type. What does this mean when you have is it because it's a texture as well? Maybe it's like an object hierarchy? Texture, get height. How? It must be an object hierarchy. Because look, we have objects in here too. So you can say what kind of object you are. You can do things that any texture can do, and then you can do these things that any image can do. Okay. And then, all right, getting back to the particle system stuff, go back to graphics. So we're kind of building up layers of understanding here. You have like the raw data that comes from some source, whether that's generated like we did with our example, or comes from an actual image file like Grok did up above here. Got if when you do new image, oh, that's straight from a, okay, so you can do new image directly, or you can create a new image from some actual in-memory image data. But then back over here, we go to all of these things. We can look at new particle system for creation. This function can be slow if called repeatedly. Yeah. This is their way of saying don't be dumb. Create your particle system in a load function. That's how I'm reading that. Okay. Let's see. I'm using the second load function with the generated image. Can you update the code to hide the mouse cursor? Okay. Let's take this. Oops. Change it. Put all that there. And then do this. So cool. Now it's following my mouse, but we don't see the annoying cursor. Write my name. Write M. Well, you can hardly tell. Okay. Let's do, well, if this is going to make some suggestions. No. Let's play with some of these parameters ourselves. I think we've got the basics. Actually, I don't want to keep moving my mouse there. So let's do this. Do I even need to do this? There's like window. Yeah, there we go. So we can do, instead of doing set position here, let's do this. Comment this out, and we'll do local mx my is equal to love window get width, and I want to do the width divided by 2, and then love window get width, but get height, sorry, height divided by 2. The goal is to just like put it right in the middle and not track it to the mouse. Whoops. Attempt to call get width a nil value. Huh? Oh, it might be a method. Did a dot. Okay. I think it's might be a method. Try that. What? Why is that being so silly? Get love window get width. Huh? I am mega confused about why that would be nil. Is that what it's saying? Attempted to call method get width a nil value. Huh. Okay. I know I'm not that bad at programming. I wanted to put the particle system in the middle of the screen. So I switched to this code. Now I'm getting a complaint about get width being a nil value. What's going on? What? The love window. Did I just not read properly? It's right here. Oh, removed in 10. So, okay. Dang it. That's so hard to notice. So it's graphics. I took it off of window and put it on graphics. Which makes sense. They said basically graphics is our place to draw all stuff. All right. There we go. Okay. So set particle lifetime. Now we can like poke around with each of these things and read about them. The particle system, the particle lifetime. Set particle lifetime. Man, I really wish they would just take out the deprecated ones. That's annoying. The maximum life of the particles in seconds. Okay, so if we just take these and go, like, will they go off screen if we, like, say 5? 1, 2, 3. Oh, yeah. Oh, that's kind of cool. Like flying through space a little bit. I feel like I'm making a... You know what it reminds me of? It's probably not far from how would they would do like the Star Trek effects. There's probably something there, like a going warp speed, where you see things are going fast. Ghost Machine, thanks. I will do my best to have a nice stream. Appreciate it. Okay, so we know. Okay, so we've got like. I don't know why there's a minimum. What would make it? What would you have a minimum for a lifetime? I mean, isn't the minimum by definition 0? Started. Oh. Is it, or is it random? What does that mean? I guess it could be like it could be that some particles will go for a long time and some will fade off. Yeah, I'm seeing, look around here. Pointing like you can see my word, I'm sorry. And I can't show you the mouse cursor because I turned it off. Ah, phooey. Let me turn the mouse cursor back on and then I'll point some stuff. So we can hide the mouse cursor but also show it by doing that. So there are some particles that are coming all the way out here. These are clearly the ones that have the longer lifetime of like 5 seconds. They go off, they have a high speed, and they're done. But then there are some that are like around here that are short, like 1, 2. So I think what this tells me is that the particles, like I have a feeling if we did, there's kind of a fade out for some of these, but if we wanted to get that effect, like that Star Trek effect, where it just kind of all the stars go past you, because you would need every single one of them to go off. So we want to have the min and the max be the same value so that they go off screen. And these ones will all, whoa. Well, okay. Oh, there's the burstiness, I guess. We've got an emission rate. Huh. Oh, you know what it must be? Because we have them all set. So it's almost like it's probably like a pool of a set of particles that they're probably reusing in memory. That's probably what makes it space efficient. And you can't re-emit one back. So if you think about it, if you have if you have 50 particles, just, I don't know that this is actually a rate, but let's just assume there are 50 particles. So you've got a chunk of 50 that get allocated, and all of them are set to 5 seconds. But the speed at which they're coming out is pretty quick. So set speed, I assume, is in milliseconds or something. The minimum linear speed of the particles. Oh, I don't really know what that means. Yeah. But if they all go out at all the same time, but they don't die until at the same moment, then if your max lifetime exceeds that rate at which you have number of particles to give, then you get that pattern where it stops and doesn't look continuous. And then they only start up again because all of the 50 die off at the same moment. So then there's another burst. So that gets that kind of bursty behavior. I think that's kind of cool though. They all go off at some speed, and then boom. Probably as soon as it stops, we could probably count to, well, as soon as we see it, 1, 2, 3, 4, 5. 1. Yeah, it's okay. I'm not a perfect stopwatch here, so let's see it when it starts. 1, 2, 3, 4, 5. Okay. So you can see that behavior there. That's cool. So how would we get that to just like keep going? So one way is we could just have a much higher emission rate. I don't know. Let's see. The emission. Set the area-based spawn. The amount of particles per second. Oh, so actually bringing it down might actually help. So if we brought it down to 10, we would have fewer of them, but they'd take longer to fan out. And it might just be we might reach a point where it's just continuous. Like we never get. Yeah, cool. And like it's like if you couldn't see, if you had something blocking this kind of middle here, then it would look like if you put the Star Trek Enterprise right here, right in the middle, it would kind of look like you're going straight through a warp field, you know, and passing stars. They don't have the streakiness of the stars that you see in that special effect in Star Trek, but I could totally see them having done something. I mean, it could be. It was also, granted, like Next Generation was like the 80s when it first came out, so they could have had a maybe non-computer generated particle systems, and maybe they just did it by hand and had special effects where somebody animated something that could be function on a loop, and you just wouldn't know because they're going by too fast, with enough difference, like a long enough loop that you just couldn't tell because it was pretty short shots when they would show the kind of going at speed stuff. Okay, so that's cool. Emission rate, so the amount of particles per second, that's a good one to know. The lifetime, so we wanted like 50 and 1, probably like the right mix where some die off quickly, so you get a... this is kind of spurty still. Interesting. Okay. We'll play with some of the other ones. We've got set speed. I still don't understand what that meant. Set the speed of the part, like how fast they move. Oh, the linear speed. So okay, like how fast they'll like shoot off the screen. So if we go, just make them both the same, like those should shoot off the screen pretty fast. Okay. All right. So they're all going at the same linear speed. What happens if you leave off one of the values? Will it just pick like the max? I just say 800. Will it just take that? Yeah, it will. Nice. Okay. That was at 100, 200. Set the spread. The amount of spread in radians. So this is like, okay, so the fact that they're saying 2 pi tells me that they want a full circle. If we do change that to 1, it should just be half, like a half a circle. Question is, which half? Maybe there's like a rotation. There's something about angle. Well, let's just see if I understood that correctly. Okay, just that way, positive. How would you make it so that it's just down? That's something we could figure out. So spread in the amount of spread. The area spread? No, that can't be it. Spin, texture. Okay, let's ask Grok. I'm playing with set spread, and I switched from 2 pi to just pi so that the particle system only does half. How do I control which half? Currently, it emits only to the right. Oh, there's a direction? Did I miss that? I did. Okay. So there's a direction in radians. All right. So we could do, and it starts out just pointed. I'm guessing it starts out just pointed at like, because it was spread completely on that half, so it must be completely on the x-axis. So if we do direction, also is pi, then that's should be the other way, right? Because if it's doing your classic like math system, then 0 radians is pointed to the right from the origin, and one radian is 180 degrees, so it should point the other direction. Cool, and it does. So if we want stuff going up, we would do a half a radian, so divided by 2. Whoops. Well, that wasn't unexpected. Is it okay? Okay, I guess it rotates down. Oh. Because the coordinate system is positive is down, right? So the rotation of that direction must be counterclockwise. Set the direction of the part. Okay. So if we made it negative pi, then it would point up. So you could start to see, or I'm starting to see, if you wanted a smoke effect, you could maybe control the spread. Like it's going straight up. You could say that's the right direction to go up. And then we want this, like if we did the spread divided by, I don't know, 8, it's going to start to be like a cone shape. Yeah. And the fact that it is a little transparent circle, like you can see some kind of smokiness there. Let's ask Grok to make some smoke. Can you update to make something that looks like smoke? Because you could take those circles and you can imagine like picking random, like a particle's size. You could randomize the size. There's a bigger circle, smaller circle, that all have that transparent effect, and just the way they would overlap, and if they were going up, think that they would get that characteristic. So particle system, we want soft billowing particles that rise slowly, spread out, and fade with a grayish or translucent appearance. We'll modify the particle image to be softer, tweak the spread direction, speed, size, color, and add slight randomization to create a natural wispy effect. Since you want the emitter fixed at the screen center, we'll keep that to ensure the smoke rises. All right, cool. So let's take their version and change it, paste it here, see how it looks. Okay. I wonder how it's getting, there's something like, oh, shoot. They've turned the cursor off. There's like a waviness to it. Maybe, is it moving the direction? Like oscillating the direction in randomness? Set the direction. 3. Okay. Let's look at these different aspects. Longer lifetime. Okay. We want fewer particles at once that move up slowly. Narrow. How is this upward? Oh, they did the full. Okay. So I did the negative math. They went 3/4 of the way around the circle. Otherwise, it's the same. I would think that the negative is faster. Who knows? Larger particles that grow. What's set sizes? Maybe that's a various sizes. Set a series of sizes by which to scale a particle sprite. 1 is normal. The particle system will interpolate between each size evenly. Ah, okay. So here, they're saying the particles, as they reach the end of their life, will be at the maximum size. But they're also like fading at a distance. I wonder what would happen if we gave it another point, because there were up to 8 of them. So if we got like, if you then like get smaller, let's say you go down like that. So there's a kind of a lifetime of the particle. That's pretty cool. I'm having fun here. But what's the size variation? Random. So like the starting point varies, maybe? Set the amount of size variation. 0 meaning no variation, 1 meaning full variation between the start and the end. How does that work in conjunction with the other thing that with the sizes? What happens if we just turn it off? I think if it's off, it takes out all the particles are the same. Well, they have different lifetimes, so it's still random. So, okay, let's try putting it back in with like full randomness. They did half of them were random. Let's do like really random. Now, interestingly, it's actually giving like the crackliness of fire to me, because those, I think what's happening is that the particles are popping out from that origin point at different random sizes each time, because we picked full randomness between each one. So it's like guaranteeing that well, not guaranteeing. It's greatly increasing the probability that at the point of origination that each one's a different size. And because of that, there's less, there's that higher variation leads to like a jumpiness at that point. So it's almost like you could imagine if that was a big enough particle, and you kind of had it behind a fire image, it might give it a little bit of a crackly feel to it. That's cool. I like that. I'll put it back to where it was though. Set the colors. Oh. So you could give multiple colors like over the lifetime. Does it work the same principle? Oh, nice. I like this little system where you've got power to control like 8 of these. So you can get some pretty flexible things here with like a lot of artistic control. Okay. So it picked 1, 2, 3, 4, 5, 6, 7, 8. What I don't understand. No, oh no, that's wrong. So these are to alpha. This is RGBA. So this is saying we've got the starting color is here of a gray, and then okay, it sets it to 0, and it interpolates over that range, right? So I guess what's happening, yep, so it's interpolating between the colors. So it's going from a lighter gray, that's 0.7. So pretty white. Or getting, if 1 is white, that's a pretty light color. Almost picking the other gray doesn't really matter because they're changing the alpha channel. So it's starting out with like 50% opacity on a gray. And then it's moving to 0% opacity on a darker gray. So I think you could probably say, you know what, forget all of this messing with gray. Let's just make this white and then play with the alpha channel alone on this black background. But I guess the trick is, if you weren't on a black background, then the alpha channel by itself is not going to work. So by picking a gray color, you could have it on a blue background, or like if it's a smoke's going into the sky or something like that, during daytime. Okay. Linear acceleration. Ooh, nice. So you can make the particles start to go faster, I guess. Set the linear acceleration along the x. Okay, which one's which? X min, Y min, X max, Y max. Okay. So zeros for the min, and then upward, that's the negative numbers for the maxes. Okay. And by doing a -20, I guess it causes it to move out. There's one more thing I want to figure out. Is like, let's see. Let's just ask all the particles are starting from a single point. How could I spread that out? In a real fire, smoke does not come from a single spot. It is spread over the whole flame. Set emission area. Uniform. Okay. Let's try it. I think after this I'm going to wrap. Played with particles. Still don't know why they're not working in our Pong game. But it's probably something that we could go back and code ourselves rather than relying on Grok to do this. Or maybe we do... Maybe it was just the image. Who knows? There's probably ways that we could start from just emit somewhere to just emit when it's being touched to whatever. Yeah, that's cool. I mean, there'd be more work to do. There's a lot more particles that would be needed, and then you'd have to put a graphic over the top of that. But that's definitely could feel like smoke. Awesome. And I think the other layers to this is like you could add color. You could, yeah, do lots of stuff. And there's one last question I want to ask it. Can particles be combined with shaders? Oh, okay. Neat. So you could have like a glowing, so I'm imagining like a pixel sprite fire. And then you put a shader on top of it to give it a glow. And your smoke wouldn't have to be, if your smoke was near it, you could cause the smoke to glow as if it's being illumined. The smoke particles, you could think the light is refracting off of them as the fire is going up, which I think would be kind of true to life, right? Like if you don't see smoke far from the fire in the dead of night, so you see it brighter by that. So that'd be kind of cool. Oh, did they give us some code? Did they actually put a shader in here? Ooh, all right, let's try it. That'd be sweet if it works. I think it's doing it on the whole thing. But okay, I don't know how much difference I notice, but it's pretty cool. Maybe like fuzzier? Neat. We'll add the particles demo. Add particles demo with a shader, I guess. Cool, that was fun. Didn't add anything to the game because Grok failed each time we tried. I'm also not committing to doing like consistency between streams here. I'm making games, but I'm also making games for fun, just like in my free time. I think just to speak to that, like a little bit, is kind of a little like I've been teaching on how to do web development for a long time, and I still do web development at work. I work on APIs. I do all that sort of stuff, and I just got to a point where it's like, well, I want to embrace this more as a hobby. So I think what I'll be doing is maybe each time I stream, I'll be working on building up the stream a little bit better. I got to figure out how to do background music a little bit more. So it's just, I'm going for a more mellow vibe with the stream. It's the casual and exploratory with no like real objective except for to learn and to have fun. There are aspects of this stream as well that I want to improve. Like I was hearing a little bit of, so these are some headphones connected to this Mac Mini. I want to get, like I have sound with that game and you can't hear it because I don't have any sort of audio capture. So I need to set up an audio capture. I need to set up background music. I'm sure that'll bring a whole new set of problems of how do I mute background music to just allow for game sound if it's in conflict. I don't know. But those are the kind of things that I think will go on. So thank you all for joining in, and hope this was fun and exploratory for you if you were watching, and I'll see you next time. Take care.